We're going to use Laplace transforms to solve an ordinary differential equation where the forcing function, or input, is a unit step function. The equation that we're going to be solving is y double prime plus y is equal to 120 times u of t minus 1. The forcing function is equal to 0, and then it turns on when t is equal to 1. Let's start by taking the Laplace transform of every term in our equation. We have the Laplace transform of y double prime plus the Laplace transform of y is equal to the Laplace transform of 120 times u of t minus 1. Over here on the right, I've written down the formulas for the Laplace transforms of derivatives. We have y double prime, so this is s squared capital Y of s minus s little y of 0 minus little y prime of 0. Those are our initial conditions. And then we have plus capital Y of s. And then on the right, we can pull out the 120 and the Laplace transform of a unit step function. Let's go up here to the top. The Laplace transform of a unit step function t minus a is equal to e to the minus as over s. And our function a is equal to 1, so this is e to the minus s divided by s. Our initial conditions are equal to 0, so these terms are going to go to 0, and we can combine our capital Y of s, so we get s squared plus 1 capital Y of s is equal to 120 e to the minus s all divided by s. Let's get capital Y of s by itself, and this gives us 120 e to the minus s all divided by s times s squared plus 1. Our solution, y of t, is the inverse Laplace transform of capital Y of s. So we need to find the inverse Laplace transform of this function. Let's think of y of s as 120 e to the minus s capital F of s. Let's first find the inverse Laplace transform of capital F of s. Using partial fractions, we're going to write f of s as 1 all divided by s times s squared plus 1. We'll split this up as a divided by s plus bs plus c. That's because we have a quadratic in the denominator, and our denominator is s squared plus 1. Let's go ahead and let's recombine this. So we have a times s squared plus 1 plus bs plus c times s all divided by s times s squared plus 1. Now we can go ahead and set 1 equal to this algebraic expression. To make things easier, I'm going to write the 1 as 0 times s squared plus 0 times s plus 1. And let's go ahead and let's multiply out the right-hand side. This is as squared plus a plus bs squared plus c times s. Our 0 is then a plus b. Our 0 times s is c times s. So we can say that 0 is equal to c. And then we have our constants, and we have a 1 equal to a. That's nice. So we know that 1 is equal to a. So that tells us up here that b is minus 1. This gives us our capital F of s is equal to 1 over s minus s all over s squared plus 1. Let's now rewrite our capital Y of s as 120 times e to the minus s times our f of s, which we just found to be 1 over s minus s all over s squared plus 1. Now we can find the inverse Laplace transform. I went ahead and wrote down the formula over here on the right. If we have e to the minus as times capital F of s, the inverse Laplace transform of this is f of t minus a times u of t minus a. Let's write down that a is equal to 1, and this is our capital F of s. So the first thing we need to do is find little f of t, and then we can shift it. The inverse Laplace transform of capital F of s is the inverse Laplace transform of 1 over s minus s over s squared plus 1. We know what both of these terms are. The inverse Laplace transform of 1 over s is just 1. And then the inverse Laplace transform of s over s squared plus 1 is cosine. So we have minus cosine t. So little f of t is 1 minus cosine t. Now let's find our answer. Little y of t is going to be the inverse Laplace transform. We'll bring our 120 down, and then we're going to have this piece right here looking over in this box, f of t minus a. So that is 1 minus cosine. A is 1, so we have cosine t minus 1. And we're going to multiply that by u of t minus a, which is t minus 1. And there's the solution to our differential equation. Notice that the solution starts at 0 because of this term right here, and then it turns on at t is equal to 1 and oscillates indefinitely. If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.